Hello all, myself Dr. Hazari Naresh. I am working as an assistant professor in Mechanical Engineering Department, VJEC, Hyderabad. Today, we are going to discuss about kinematic chain and inversions in kinematics of machinery subject. Okay. First, the inversions. What is inversions? So we have learned about the mechanisms. Now here we are discuss about the inversions of mechanisms. So first simple, if when one of the link is fixed in kinematic chain, okay, so kinematic chain, this link is fixed, then we call as a mechanism. Okay, now the method of obtaining different mechanism by fixing different links in a kinematic chain. Different link in kinematic chain. This kinematic chain we are going to fix. In this kinematic chain we are going to fix more than one link. So how? There are some different arrangements are there. So these different arrangements are known as the inversions of the mechanism. Okay. So the method of obtaining different mechanism by fixing different links in kinematic chain. In a kinematic chain, we are fixing different links. If one link is fixed, then we call it a mechanism. So next, now the types of kinematic chains. So first, there are three different types of kinematic chains are there. So first one is 4-bar chain, or we call as a quadric cyclic chain. So here it consists of 4 links. 4 links are binary joint where one link is fixed. The link 1 is fixed. 4 all are turning pairs ABCD. 4 links may be at different lengths. Now why I am mentioning in different lengths here? So according to the Groshoff law, for a 4-bar mechanism, the sum of shortest link, okay, and sum of longest link, sum of shortest link and sum of longest link should not be greater than the sum of remaining link. So this should not, this link 4 and link 2 should not be greater than link 3 and link 1. Link 1. The remaining 2 link lengths, if there is to be continuous relative motion between the 2 links, so this condition is satisfied, then only we can transmit the 1 degree of freedom. Okay. See, shortest link, longest link should not be greater than the sum of the remaining 2 links. So 4 plus 2 and 3 plus 1. So wiper mechanism and robot arm. Next, single slider crank chain. What is single slider? Namely itself single slider. So in this mechanism, so in this chain, only one is slider. So it's called as a single slider crank chain mechanism. Okay. So it consists of 1 sliding pair and 3 turning pairs. 1 sliding pair and 3 turning pairs. Example, reciprocating steam engine mechanism. Okay. Double slider crank chain. So this double slider, namely itself double 2 sliders are there. Here 1 slider which moves in this guideways, 1 slider moves in this guideways. This is called as a double slider, a kinematic chain which consists of 2 turning pairs. Here these 2 are turning pairs. These 2 are turning pairs, 2 sliding pairs. Okay, 2 turning pairs and 2 sliding pairs is known as double slider crank chain. Examples are reciprocating engine and compressor, rotary engines, oscillating engines, hand pump for a bore well. These are the examples of double-sided crank chain. Next, inversions of 4-bar chain. So the inversions are 3 types: beam engine, coupling rod locomotive, Watt's indicator mechanism. So first, beam engine was called as a crank and lever mechanism. So here simple, more than one link is fixed. First let us see here the link 1 frame, like it's a frame, link 1 is frame. Link 2 is a crank. Link 3, okay, it's a connecting rod, it is a lever. Link 4, it is a lever. So here what will happen, it consists of 4 links. When the crank rotates about the fixed center A, this cranks rotate about the fixed center A, cranks rotates about the fixed center A, the lever oscillates about the fixed center D. So here the crank is fixed here, the lever is also fixed, more than one link is fixed, that is satisfied. So here what will happen, when this T frame, if the crank rotates, the connecting rod, this link 3 which is connected to this lever to the crank. So when it is on a rotation motion, lever will tries to oscillate about the fixed point D. So the purpose of this mechanism is to convert the rotary motion into reciprocating motion. Okay, now here it is in oscillating motion, tries to move in oscillating motion. Now here what will happen, here we are going to arrange some cylinders or something, or some like hammering, so mechanical hammers we are going to arrange here, or we can arrange pumps, or we can arrange any kind of cylinders. So here the piston rod is connected here, it tries to always move in up and down motion. Okay, so this purpose it will, beam engine will works. Next, coupling rod of a locomotive. So named itself locomotive. So this mechanism, double crank mechanism, this will used in locomotive engine, where we are going to pull the forces. We are going to supply power to one wheel, the same power is supplied to the another wheel with the help of coupling rod. So it consists of, so first you can see link 1, it consists of 4 links, link 1 and link 3 having the equal lengths, link 1 and link 3 having the equal lengths. Link 2 acts as a coupling rod, link 2 acts as a coupling rod, and link 1 is fixed in order to maintain the constant center to center distance between them. So we are transmitting power from one wheel, let us consider B to the A, or vice versa, or if you consider if you are going to supply power to here, in this condition, if it is in rotation motion, the same power is transmitted here, then it starts rotation here. Okay, this way it will going to works. This is called as a coupling rod of locomotive. This is used in locomotive engine. Next, Watt indicator mechanism, or we can say that double lever mechanism. So here see, it consists of 4 links. Again it is a 4 link, but you are seeing, while you seeing the many links are there. So 4 links, so fixed link at A, so you can see this is a fixed link at A, the link AC, so link AC, so this is your link 1, this is your link 2, this is your link 3, this is your link 4. It is nothing but considered as a single part. So it may be noted that BF and FD, so BF and FD, BF and FD form one link because those two parts have no relative motion between them. The links CE and BFD, the link CE and BFD, these two are acts as a lever. Okay, this produces straight line. When it is moving in this direction, then the point E will move to point E dash. So here exact straight line motion is produced. This straight line motion is produced. So here we are the movement of point F, which is produced by the some cylinder. So by this way it will move up and down. So with the help of this we are going to produce the straight lines. Now inversions of single strider crank chain. So here there are 5 types: pendulum type or bull engine, oscillating engine or oscillating cylinder engine, rotary internal combustion engine, or we can say Grom engine, crank and slotted lever, quick return motion mechanism, Whitworth quick return motion mechanism. There are 5 types. Let's see. First one is pendulum or bull engine. So this is a inversion is obtained by fixing the cylinder 4. Here what will happen? First let us see link 1, it is a piston rod. Link 1 is a piston rod. Link 2, it is a crank. This is under rotational motion. Link 3, it is your connecting rod. Link 4, cylinders. This part is cylinder, it is fixed. What will happen? Here see, exactly here you can observe here. Here the red color link which is in under rotation motion, the connecting rod is fixed at point A. The connecting rod is fixed at point A. Now the connecting rod and crank are fixed at a particular point. Okay, in this joint, when it is under rotation motion, it tries to move in pivot points in this direction. So here it is produced in this direction. Now based on this, here this crank is again connected to the piston rod. Here in this piston rod which is connected to the 2 pistons. Okay. Now when it is in rotation motion, this piston rod slides moves up and down. By this way this pendulum pump or bull engine works. So two way we are going to produce power. So let's keep here one inlet. Let's keep here one more inlet outlet. So with the help of this we are going to produce a double power with the help of single rotation. Next, oscillating cylinder engine. So oscillating cylinder means cylinder is oscillating manner. So first let us see piston rod. Let us say link piston rod. This is link 1. Okay. Next crank. This is link 2. It is on rotation motion. And link 3, it is acts like a connecting rod. Next, cylinder is considered as a link 4. So when the crank link 2 rotates, the piston attached to the piston rod link 1, this link 1 reciprocates. Link 1 reciprocates. Here one is piston is attached, and the cylinder link 4 oscillates about the pin pivot. Now this is under cylinder. Here somewhere point is fixed. By this fixed point the cylinder is oscillating. This comes to here, the cylinder is oscillating. Cylinder is oscillating. So where we are going to use this type? So in older days, in past, mainly used on ships and small stationary engines. So nowadays we are not going to use, because when it is continuously oscillating, there is a chance of hazardous. Okay, there is a chance of damages and high wear and tear. So that's why we are not using recent. So rotary internal combustion engine, or we call as a GROM engine. It consists of 7 cylinders in one place and all revolves about the fixed center. So here again cylinder 1, so cylinder 2, cylinder 3, cylinder 4. So there are n number of cylinders are there, so 7 cylinders are there. Now this is commonly connected, so the piston here, the piston, this comes as a link 3. Now this link 2 fixed crank 2, here the fixed crank 2. Now here connecting rod, it's connecting rod fixed crank. So it's link 1, link 2, link 3, fixed crank. So when this crank in rotational motion, then this is connected to the n number of connecting rods. So like 7. So each having some pistons, and this piston is oscillating in cylinders. So here when with the help of one rotation, all the pistons are moving simultaneously. So here this type of engines are used in aviation purpose. So for where high speed is required, for that we can use this kind of GROM engines. Or if you want to reduce the vibrations, so for example if you consider, for example this IC engine mechanism, for example piston is cylinder. So if once a rotation piston, then what will happen, there are inertia force are produced, there is some kind of vibrations are there. So that's why we call as a reciprocal engines are partially balanced engines. So where this kind of inertia forces are not present here, means these forces are completely balanced with the help of opposite cylinders. So for high speed applications where we are going to reduce vibration, we can use this kind of GROM engines. See working animation. Next, crank and slotted lever quick return motion mechanism. Here what will happen? Here see this animation. So this way shaper machine will works. Here let us consider slider first link 1. This is your slider. Here one part is there, slider. Now link 2, this is your crank. So crank. Link 3 fixed. Link 4 slotted bar. Okay, link 1, 2, 3, 4. How it will going to works? So let's consider the link AC. The link 3 forming the turning pair is fixed. So link 3 is fixed. Link 3 is fixed, man. Next, the link 3 correspond to the connecting rod of the reciprocating steam engine. The driving crank CB revolves. Driving crank CB. C is connected to the fixed link and B is nothing but it is a slider. Uniform angular speed about the fixed center C. A sliding block attached to the crank pin at B slides along the slotted bar AP. So here B is slider bar. This slider bar sliding in slotted bar. That is nothing but your link 4. Slider bar link 4. AP. This is your AP. To oscillate about the pivot points A. So again this link 4 slotted bar is again fixed. The point is A. This A nothing but is fixed to the link 3. So this way it will go into fixed. A shorter link PR transmits, shorter link PR transmit the motion from AP, from here to here motion from AP to the arm which carries the tool and reciprocates along the line of stroke R1 and R2. Line of stroke R1 and R2. The line of stroke of the ram R1 and R2 is perpendicular to the AC produced, perpendicular to AC produced. So finally here this is one link, link 1, and this is your link 2, this is your link 3, and this is link 4. Now when it is rotating in this direction, what will happen? The slider inside this slotted bar is sliding on the slotted bar, which is tries to move this slotted bar from point P1 to P2, means which is moving from P1 to P2. Now when which moves P1 to P2, the point B here, the point B is moving from B1 to B2, where this travel considered as a beta, this travel is considered as a alpha. So while this is a longer path and this is a shorter path, means while cutting stroke moving slowly, return stroke coming fast. Okay, cutting stroke slowly moving towards the workpiece, and while coming back it immediately comes to backside. That's why called as a quick return motion mechanism. Quick return motion mechanism. Okay, so here few things we have to learn here. So time of cutting stroke to the time of return stroke. So as say beta alpha. Beta is called time of travel. So here angle you can consider from here to here. Let's consider beta, and alpha is equal 360 minus beta is equal 360 degrees minus alpha by alpha. So since the tool travel distance R1, R2 during the cutting and return stroke, therefore travel of the tool or length of the stroke is nothing but R1 to R2, where R1 to R2 is equal to P1 to P2. R1 to R1 is equal P1 to P2. The same we are going to write as 2P1Q, 2P1Q or QP2. Now same P1Q we are going to write as 2AP1, 2AP1 sine of angle P1AQ, angle P1AQ. Now the same we are going to write as 2AP1 sine 90 degrees minus alpha by 2, which is equal to sine AP cos alpha by 2. Sine 90 degrees minus alpha by 2 is equal to AP cos alpha by 2. Now 2AP into CB1, alpha is equal to CB1. So where alpha by AC. Now finally we will get cos alpha by 2 is equal to CB1 by AC. So the total tool travel R1, R2 is equal to 2AP into CB by AC. Same nothing but 2AP from here to here by CB by AC. This is your tool travel. Okay. Next, Whitworth quick return motion mechanism. This is also same kind, but the arrangement is a little bit different. So now this mechanism. So here in this mechanism, it is mostly used in shaping and slotting machines. Okay. So the link CD, link 2. So first let's find the link, various links. So slotted bar. This is your slotted bar. Complete is a slotted bar. And link 2, it is a fixed link. Link 3, it is your crank. This is your crank. Link 4, slider. Here it is a slider. It is a slider. It is a slider. So how it will works? The link CD CD forming the fixed turning pair. So this is fixed turning pair. The driving crank CA link 3, the driving crank CA, that is your link 3, rotates at uniform angular speed, which rotates in uniform angular speed. Then the slider 4, which is fixed in slotted bar, attached to the crank pin at A, slides along this slotted bar PA. This slotted bar PA slides along this slotted bar PA. So link 1, which oscillates at a pivoted point D. Okay, so this way, when this is under rotational motion, what will happen? The point P tries to produce a circulatory motion. By this point P to the ram, one connecting rod is attached. On this ram, tool is attached. When it is under moving direction, again same, well, moving stroke means cutting stroke, move slowly, and return stroke come as quickly as possible. Okay, generally we are going defined by 3:2 ratio. So this way is with what quick turn motion mechanism will works. Now same here, same time of cutting stroke to the time of return stroke, alpha by beta, alpha 360 minus alpha. Here 360 degrees minus beta by beta. Okay. Now inversions of double slider crank chain. Here double slider means two sliders are there. So first one is elliptical trammel, Scotch yoke mechanism, Oldham's coupling. First elliptical trammel. So elliptical trammel, here you can see that the two sliders. So first slider, link 1 is slider. So slider means here B, link 2, it is a bar, link 3 again slider, link 4 slotted plate, this slotted plate. Now this inversion is obtained by fixing this slotted plate. Here this is fixed, this slotted plate is fixed. The fixed plate link 4 has two straight grooves cut in it at right angle to each other. Next, the link 1 and link 3 are known as sliders. Link 1, link 3 known as sliders. Sliding pairs, link 4. The link AB, link 2, the link AB or the link 2 is a bar which forms turning pair with link 1 and 3. Here link 1 and 3, these are turning pairs, these are sliders. Okay, when the link 1 and 3 slides along their respective grooves, any point on the link 2 such as P traces out an ellipse on the surface of link 4. So this point P, when it is under rotation motion, see here, this 2 are rotation motion, this is tracking. See any point, let's say this point is tracking here, like this point is tracking. On this point it tries to produce elliptical motion. If you are tracking on another point here, it is also produces one more elliptical motion. So this elliptical motion is possible with the help of elliptical trammel. Actual conception will show that AP and BP are semi-major axis and semi-minor axis of the ellipse respectively. This can be proved as follows. Okay. Next, Scotch yoke mechanism. So this mechanism is used for converting rotary motion into a reciprocating motion. Here we are saying the Scotch yoke means here it is comes under the double slider. Okay. The inversions is obtained by fixing either link 1 or link 3. Link 1 is fixed. In this mechanism, when the link 2 correspond to the crank rotates about the B, this is rotates about the B as a center, rotates about the B, the fixed link 1 guides the frame. So first link 1, link 2 it is your crank, link 3 is your slider, link 4 is frame. It's complete frame. Okay, next, Oldham's coupling. So Oldham's coupling, this is generally if the distance between two axes are there, then you are preferred this type of joint. So Oldham coupling, it has 3 discs. This comes under again double slider. When here one sliding surface, here one more sliding surface. So 3 discs. One first see this parts. So flange 1, link 1 is your flange. Say this is your flange, and link 2 is a supporting frame, and link 3 is your flange on another end, and link 4 is your intermediate piece. So this intermediate piece is kept in between flange 1 and flange 2. So here it's having some grooves. So it has 3 discs, one coupled to the input, one coupled to the output. So this is your driving shaft, this is your driven shaft, input and output, and a middle disc. So intermediate piece, the middle disc that has joined to the first 2 by tongue and groove. Here in between this first one, tongue and grooves, the tongue and the groove on one side is perpendicular to the tongue and groove on another side, like it is your plus shape. So one is in this direction, tongue and groove, on here groove is there, on another side here tongue and groove is there, this side. So when it is under rotation motion, see here what exactly is happening on this disc. When it is under rotation motion, this sliding one, let us consider flange 1 and intermediate link, this is in sliding motion. Parallelly, the same sliding motion is happening on another side of this intermediate piece to the another flange link 3, which is connected to the output. So this is to driving shaft input, this is connected to the driven shaft output. So like these 2 slidings are happening simultaneously. So this is called as a Oldham coupling. So parallel shaft whose axes are at a small distance. So for example, we are going transmitting shaft. Let's say it's a driving shaft axis, and this is your driven shaft axis. So the distance between driving and driven shafts are, let us consider as a x. So if there is some x distance between driving and driven shaft axis, so we are going to use this type of couplings. This is called as a Oldham coupling. Next, if you are intermittent motion, I'm going to show you. So the intermittent motion mechanism, or we call as a intermittent movement, is a device by which film is regularly advanced and then held in a place for a brief duration of the time. So for a particular time it will go into held, like your in automobile shop lines. So automobile assembly line. So when assembly lines are moving, say from this distance, let's say this is point A and this point B, C and D. The line is moving from A point to D point. So each point takes say 15 minutes. So we are going to arrange such type of mechanism, such type intermittent motion mechanism, where the mechanism should be run at a 15 minutes duration of time. So which tries to move from A point to B point, where it stop for 15 minutes, and from here to here to stop for 15 minutes. Here it is 15 minutes. For example, here if you consider in this mechanism, so each assembly point which is going to stop for a particular time. So where we are going to do some assembly operations or some fitting, anything. So these are few kind of intermittent motion mechanisms. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.